Hello everyone, welcome to QPT. Aviation has grown considerably in recent decades and accounts for approximately 2% of global carbon dioxide emissions and some 4% of all climate change impacts annually. While aviation is an important contributor to climate change and other environmental problems, electrification is one option for reducing these environmental impacts. The first electric aircraft are already in operation today and are mainly small planes used for pilot training and short flights in the immediate area. This is the type of plane that was studied in the life cycle assessment. In the short-term future, battery-powered electric aircraft will probably mostly be used for shorter distances, such as what in Norway is called fjord hopping, meaning shorter flights between deep fjords. In a larger perspective, the study shows that battery-powered electric aircraft have the potential to significantly reduce environmental impacts of aviation, says Richard Arvidsson, the lead author of the study from Chalmers. The team examined a commercially available battery electric aircraft with 2 seats, the Pipistrel Alpha Electro, in the life cycle assessment. The same aircraft is also available as a fossil fuel powered model, enabling the researchers to make a direct comparison. The team investigated the entire impact of each aircraft from cradle to grave, from raw material extraction to end of life, with a functional unit of 1 hour flight time. Data and records from the aircraft manufacturer informed much of the study. A wide range of impact categories were considered, with a focus on global warming from greenhouse gas emissions, example carbon dioxide, mineral resource scarcity from the use of rare minerals, example lithium for the batteries, particulate matter formation from particle emissions, acidification from acidic emissions, example nitrogen oxides, and ground level ozone formation from emissions of nitrogen oxides and hydrocarbons. The key take home from this study is that small electric aircraft can have a notably lower climate impact, up to 60% less, and other types of environmental impacts than equivalent fossil fueled aircraft. However, there is a trade-off regarding mineral resource scarcity, about 50% more even in the most favorable scenario, mainly due to rare metals in the batteries of the electric aircraft, says Richard Arvidsson. As with electric cars, the electric aircraft is comparatively worse from a climate point of view when the plane is brand new, since the production of the battery consumes a lot of energy and resources. Then over time, the relative impact decreases as the electric plane is in use and its benefits are realized, namely emission-free electric propulsion. The longer the electric plane is used, the better it becomes for the environment, and eventually a break-even point is reached. After approximately 1000 flight hours, the electric aircraft overtakes the fossil fuel aircraft in terms of less climate impact, after which the electric aircraft is better for the environment. The estimated lifespan of the aircraft is at least 4000 hours, or 4 times as long as the break-even time. The lifetime of the lithium-ion batteries, however, would have to be about twice as long for the mineral resource scarcity to be about the same for the electric airplane and the fossil fuel aircraft. Alternatively, have double the energy storage capacity such that only 1 of 2 packs are needed on board for the same flight time, says senior researcher Anders Notelov, one of the other authors of the study. In the study, the researchers discussed the further development of batteries as a major step towards reduced life cycle impacts of the electric aircraft. Already today, but after the study was carried out, the manufacturer of the aircraft model have managed to extend the life of the batteries as much as 3 times. New battery technologies could further improve both climate impacts and mineral resource scarcity. There is a constant development of lithium-ion batteries that can improve the environmental performance of the electric aircraft and make it relatively even more preferable than the fossil-fueled one. There are also new battery technologies that could be developed and be applied to electric aircraft in a longer time perspective, such as lithium-sulfur batteries, although these are still in an early phase of technology development, says Richard Arvidsson. Thanks for watching this video. Find the link in the description of this video to get these 3 useful ebooks for just $5.99. Use this offer before it ends. Thanks.